Hello, folks. Welcome to the Routing Loop, our weekly show on anything to do with networking. My name is Tom Adamski. I'm a principal solutions architect focusing on things related to networking. I have two guests with me today, Evgeny and Shakil. And as part of this Q1 sessions that we run this quarter, we're focusing on bringing in Shock Talks that we've run at reInvent, our big event at the end of the year. So these were the top-rated Shock Talks that we had from reInvent. I think this is the penultimate session. We might have one or two more. If you need to find out what's coming, you can go to our page, theroutingloop.net, and find out what are the upcoming sessions. So I'll let my colleagues here, Shakil and Evgeny, introduce themselves. Before I do that, I just want to show you guys the predicament we're in this week. Normally, when we're doing these sessions, every one of us is in a completely different room. Today, we are making an exception. All of us are at a big event in Washington, D.C. So we're actually in the same room, presenting to you, coming to you from the same room. So let me just set up my camera again. But normally, Shakil and Evgeny actually in a completely different location. I'll let them introduce themselves and tell us where they're based. So maybe Evgeny.
Thanks, Evgeny. My name is Shakil Ahmed. I'm still jet lagged, unlike Evgeny. I'm based out of Australia, so we came a long way from here, and great to be back in Washington again. As a day job, I lead all the specialist functions in APJ for AWS and day-to-day work.
I think we have issues with the okay, I think we're having some issues with the audio. Evgeny, I don't think you went off of mute. I think you were still on mute when you were talking.
Oh, really?
Yeah, it's still. I don't think it's still working. I don't know what's going on. It was working, guys. We tested it before joining, and we could hear Evgeny pretty well, loud and clear. So the other option, Evgeny, is you might have to swing by and use my computer and actually join me here and talk to
no worries. Just keep yourself off mute then, I guess, Tom. So folks, once again, good morning, afternoon, or whatever time zone you're looking this from. But we're a long way away from home. I'm Evgeny Dragunov. I'm based typically in Sydney, Australia, and I lead during daytime a team of solution architects that covers customers in Australia and New Zealand. And by night, I usually work with customers around networking and help them out with networking things. I've been with AWS for 11 years, and glad to be here. And I'll hand over to Shakil.
Hey guys.
Hopefully you can hear me again. I've just put myself off mute. I'm Shakil Ahmed, based out of Melbourne in Australia, still quite jet lagged, unlike Evgeny. So great to be back in Washington, D.C. and meeting with the like minds of networking here. As a day job, I lead all the specialist functions in APJ for our customers. And just like Evgeny, at nighttime, we do networking. And in my previous roles, I used to head the networking specialist in APJ and been around the block for close to 7 years in AWS now. So great to be here. Hoping it will be a great show and keep your questions coming.
Do you guys want to maybe talk about what you're going to talk about to us today? And we can probably bubble up your presentation. But if I understand correctly, you're going to be focusing on connectivity patterns to third parties, kind of external parties from AWS to external parties, and all sorts of different directions. Is that right?
Yeah. Maybe I'll do a quick introduction of the topic. So that's exactly right. We're going to focus on connectivity patterns A lot of customers when they have quite sophisticated networks, they decide on a number of different patterns that they will use with their different partners, like third parties. So this are typically not like a consumers, anonymous users I'm talking about, but those are like your business partners, maybe third parties that you typically know about, and you need some sort of connectivity pattern to maybe send some traffic to them, or maybe they're extending some traffic to you, or maybe it's actually going bidirectionally in both directions. And so typically our customers that we talk to, they'll have a set of patterns for those use cases, which are pre-approved, kind of they've gone through security validation and things like that, and they really know how to run and operate them and provision them on time. And so this is really what the talk is about. And as we go along, feel free to ask questions, right? Tom will pause and read out some of the most interesting questions that he wants us to answer live. But otherwise, Tom will probably just type up the answer in some of the platforms that we're broadcasting this to. This is what the talk is about. And maybe I'll get Shaquille to introduce our kind of baseline where we start.
Yeah, absolutely. So feel free to, we'll try to keep the talk like at 200 level, but feel free to drop in questions, even if you have advanced questions at all. For a base, let's talk about a cloud customer and very, bare bones connectivity. We have one VPC, VPC1, VPC2, where we have the workloads. And to connect these two VPCs together, you probably are using, core network today using AWS Cloud WAN, or you might be using AWS Transit Gateway. I mean, it doesn't change the pattern as such, but you could be using either one of those to connect the workloads today. From there onwards, you might have options. You might have requirements to, talk to on-premises, the third parties, your identity providers. So you might have different kind of, requirements. So generally speaking, when you're working, for example, in a FSI segment, you probably need to talk to some identity provider to verify your identity, or printing firms where you need to print the credit cards, and also pretty much every kind of workload will require some sort of connectivity going away from the cloud network in some way or form. And if those requirements have to go to a third party, that's what we're going to talk about from here. Evgeny?
All right, thanks for introducing our customer. So as I mentioned before, here's the three types of connectivity patterns that we see often used with our customers. Outbound, identity verification, credit checks, talking to external API, so things that Shaquille already mentioned. Inbound, this is where you want to provide access to parties. So you might be providing API access and maybe like selling it. Maybe that's your business, your SaaS company. Maybe for your SaaS software that you actually use, they need to be able to talk to like a data source within your network. And so that's a SaaS integration. A good example of that is, for example, business intelligence tooling as a good example of that. And so, there's many kind of requirements that you might have there. And there's also bidirectional requirements. So enterprise applications, quite often chatty, sort of traffic can go in two directions. Your enterprise might be acquiring another business, and so you're setting up as part of that acquisition, you're kind of merging networks, but in order to do so and maybe migrate and merge these applications, quite often you need to establish just bidirectional connectivity and traffic flows in order for things to start working together. There could be proprietary protocol. Sometimes they need to make an outbound connection before allowing inbound traffic. So there's occasionally we see examples of that. And those tend to be a bit more complicated because in this case, you need to do a bit of routing between the two networks. You might be finding things like IP overlap. There's quite a few considerations when you get to bidirectional connectivity patterns.
So I got a few clarification questions on this one. So ultimately, it sounds like we're talking about any kind of connectivity outside of AWS, right? So you have your stuff on AWS, and you might have connectivity to any destination, whether it's on-premise or your client somewhere on the internet connecting to your resources. So it's ultimately all of those use cases. Would that be the way is that the case?
Yeah, you could say that, but I think the distinction with the specific chalk talk that we did at Reinvent last year was that we focused really on those identities or third parties, and not really talking about like a consumer API access that you would make available on the internet for like anonymous clients to talk
Got
to.
it. So when we're talking inbound, we're saying a third party consuming your API, not necessarily your client. The patterns might actually be similar, but your focus is primarily on those third parties.
Yeah, those patterns certainly can overlap in some cases. Like you want to set up bidirectional routing private network of your consumer, for example, that wants to talk to the API. But there tends to be some overlap in some cases between the patterns.
And then I got another question on the outbound, inbound, and bidirectional. So your the differences here is who is initiating the connection, right? So with outbound scenario, something in AWS initiates a connection out. With the inbound scenario, something outside of AWS initiates a connection to connect in. But what about the bidirectional? Does it mean that you have resources that initiate connections out, but also other things that initiate connections in? Is that the differentiation?
Correct. That's exactly right. So with the bidirectional use case, you'll probably have some applications which are sending data out and also receiving the data. And in some layman terms, you can call it B2B connections rather than B2C. I know Evgeny highlighted that same thing as well. Like this patterns or the talk we are doing today is probably going to focus on the B2B connections where a business application is talking to another business application rather than a B2C connection, which is like a business to consumer where consumers are consuming your services, etc. as well.
Gotcha. That makes sense.
Cool. All right. So what are we going to do now? We've got to focus on the outbound patterns, and so I'm going to get us started with that. Now, during the reInvent, which is our largest conference of the year, we actually jumped on the whiteboard and we draw quite all of that, but that format doesn't necessarily work for the virtual kind of presentation mode. So what we've done instead, we actually have a lot of the things that we would draw out already here in front of you on the slide. And so think about a number of different use cases, right? But what I'm going to do, I'm actually going to go and move the mouse towards the one that I talked about. And so you kind of see that highlighted, okay, with the red dot. So the first one I'm going to talk about is just your application that sits inside of EC2, okay? So that application needs to make an outbound connectivity to your business partner, to that third party. Now, in many cases, that connectivity can be done just over the internet. Okay, so think about maybe let's say some sort of API that this third party is providing to you. You might be calling them and authenticating. Maybe they can use some sort of API key, some sort of way to authenticate against it, so they know that you're calling them and you're getting authorization and authenticate as part of this request to call the right resources. Okay, a good example of that would be something like credit check. So an API that's available. So you might have a client coming to you, providing you some identity information, and then you want to verify, is that legit? Is it valid? And so as part of it, the APIs out there provided by maybe third-party companies or government agencies that will to go and programmatic and dynamically verify that. And so as part of it, you'll make a call out to the internet. For that, you'd need things like Internet Gateway, quite obvious, to go and access that application through the VPC, right? And also, in order to make that connectivity secure, you'd want to only allow really for the traffic out of your VPC to go through to allow destinations, right? And that's where you see that sort of firewall icon there. So our customers do that pattern in many different ways. One of the ways would be to deploy something called an egress proxy, okay? So the traffic will go through that proxy. We'll do a bit of filtering there. You might want to go and allow list like very specific APIs, specific destinations, and really not allow the traffic to go anywhere else because there might be a sensitive information within that VPC, and you really want to protect your environment. There could be other ways to protect that. You could be doing, more maybe basic check and do egress filtering to specific IP addresses, or you could go a much more sophisticated way and have firewall deployed there and doing things like opening up TLS and actually looking at the body of the request. So there's many different ways of kind of approaching that, but in many cases you would want to have some sort of additional security and not just allow from the VPC to anywhere. Okay, this is the most basic kind of way of doing it. Now, in many cases, our customers will have many different applications. Sometimes they'll have microservices, and so they'll have more than one VPC with their applications. And so at that stage, it's not really feasible anymore for them to go and have that set of controls and all the necessary infrastructure for each one of those VPCs that they have. And that's where cloud kind of network core comes in. That's where your transit gateway and cloud WAN. And from there, you can actually go and do a couple of other patterns. So the first pattern is to have an egress VPC. And so that's kind of a centralized point that will allow you to go still across the internet, still across to that API, but it's a centralized point where you can deploy things like your NAT gateway, internet gateway, and also your filtering capability. Okay, so you kind of have scalability that the cloud provides to you, and you could go and elastically scale your applications into many VPCs, into many components and things like that, but still have that egress capability as well as security in this case. Now, one common pattern that we see with our customers to do that is to centralize that egress, inspection and capability. And so, with that pattern, what actually happens is that the customer will deploy something called inspection, or maybe sometimes you hear it's called security VPC. And inside that inspection VPC, they can deploy things like AWS Network Firewall, so a native firewall service. They'll deploy it once, and it's able to go and protect traffic across many VPCs. Or they might go and bring a third-party appliance from one of the leading security vendors that's available from the AWS marketplace. So again, that pattern kind of works with different options of what actually does the security under the hood, but the pattern is actually universal, irrespective whether you go with something like AWS Network Firewall, or if you go through a third-party solution of marketplace, maybe something like Palo Alto Firewall, or maybe Fortinet Firewall. So there's many different options there.
All right. I got a question again for you and Shakir for you guys.
Yeah, absolutely, Tom.
So you talked about the access to the internet through an individual VPC and potentially putting firewalling inside of that VPC and controlling that access outbound, maybe based on IP addresses, maybe based on the domain you're connecting to. The other option you presented was we can centralize that whole infrastructure and then have multiple VPCs share that egress. Could you talk about why would customers do it? Why would I centralize my egress to the internet versus setting up control points in every individual VPC?
Look, generally, one perspective would be simplification of one central place where you can actually deploy the policy in a central location. The platform team can deploy, and from there onwards, that one central location can be like a choke point where you need to have a policy and inspect the traffic before it goes out. You can do the same thing in VPCs, but then if you have hundreds of VPCs, for example, it will become a challenge. You can automate everything, you can do that, but then you are maintaining individual policies at each and every firewall level. Depending on some culture of the team, it may work perfectly fine. When generally teams are autonomous, they are good technically, they can operate those stuff, but in general, a lot of customers would try to centralize it. Not only that, centralization also brings you the cost benefit, right? So compare yourself like where you're deploying hundreds of firewalls in several VPCs, and then you have one central location where you're potentially inspecting everything. So it gives you like a sort of a one window where you can actually inspect the traffic and then do the logging and just make it an enforcement point before the traffic goes out to any third party. So in summary, I would say like it depends as an architect, as we all do, but I lean towards a central inspection VPC, which actually allows us to have a greater control, and platform teams can actually enforce the security policies of the company. Evgeny, you have to add?
Yeah, look, I think good points around like the cost, the simplicity of that deployment and reuse the infrastructure, right? I'll probably add that there are more advanced patterns. Some of those firewalls, they can support like multiple endpoints that you could actually have a centralized version of the firewall with like a single policy or multiple policies within that central firewall, but also have endpoints in those multiple VPCs. Yes, it's a bit more costly to deploy, but you kind of sort of get both of the best of both worlds with that. However, it's a lot harder to deploy and even reason about it and think about it. In here with the centralized kind of model, you can just deploy like additional VPCs, hook them up to your transit gateway or core Cloud WAN, core network edge, and things basically like work as long as routing and the policy allows traffic to go out. Whereas if you're doing that more sophisticated model with multiple endpoints, like now you also need to deploy an endpoint. You also need to configure like local routing within each VPC after you deploy it, right? So that has to be like a stage deployment to this point. So yeah, there's like more consideration and a lot more advanced. But like majority of customers, absolute majority, just having VPCs going through a centralized egress works for them, right? And that's actually the use case where they want to do double loss prevention and really like secure that outbound access from the environment. That addresses their needs.
Yeah, because I guess even when you think about the NAT gateway, right? And the gateway can do 100 gigabits second throughput per AZ. So, but you pay hourly for each NAT gateway you deploy. So if you have 100 VPCs and they each need to do maybe like 1 gig to the internet, so now you're deploying this monster of a thing, NAT gateway that can do 100 gig in every VPC. You're paying hourly, but your utilization is kind of not optimal. So I see how it makes sense to centralize, to have that beefy NAT gateway or firewall stack in a central VPC that can do hundreds of gigs. And if you're getting close to capacity, you can probably like start sharding that environment as well. But are there any downsides? Because I guess from a cost point of view, sacrificing you're removing the hourly cost, like a lot of NAT gateways, but you're adding a little bit of extra cost for having to go through the transit gateway. So I guess there would be some kind of breaking point where if every VPC is actually hammering the 100 gigs, maybe that makes sense for them to have individual NAT gateways or firewall stacks. What do you have thoughts on that, guys?
Yeah, look, there's obviously different use cases, and as Shaquille mentioned before, like if you're doing lots and lots of traffic, like doing distributed egress actually starts making sense because there's an extra cost of sending traffic up to inspection VPC and then kind of happening back into your network core. Yes, there's definitely consideration with that, but if your environment is not doing a lot of traffic, that's probably works. You could definitely do the math and kind of have a look at it, or maybe use this pattern as a starting point. And then as you kind of progress, you can go and break out egress for some of the more sort of noisy VPCs, I guess, in terms of that traffic, right? But I think as a starting point, it works, again, for most of the use cases. And, if you've got specific VPCs, yes, they send a lot of traffic. Yeah, sure, fair enough. Like, let's deploy a separate network security stack in there, sending traffic into the network core, and egress kind of locally with that distributed egress capability.
Got it. So it sounds like the rule of thumb for egress is things centralized first, and then if there's reasons that maybe you have very high load on a particular VPC, maybe that VPC would get its own egress stack. Ultimately, you can probably start off with looking at a centralized egress for all of your VPCs if you're starting from scratch.
Yeah, absolutely. I think one thing I'll add is it's also culture. Like distributed VPC design, distributed security is hard. It requires a lot of discipline from the teams who are operating that distributed model, because you can actually breach security if you're not doing it properly, because you're trusting the people who are running those workloads in those VPCs to do the right thing. I mean, you can do compliance checks and you can passively check it, but it's hard to do that as well. So I would also question, like, it depends on your culture. If you have really, really good cloud platform people or workload people who are operating in those VPCs and they know what they're doing, as long as they know, perfectly fine. But if you believe that your culture is not there yet, and then a platform team or a central team needs to mandate the security at a central level, then absolutely you're right. Central inspection VPC or security VPC should be a start, and then eventually, if you get there, sure, distributed can be an option.
Yeah, very helpful.
Cool. Okay, so I think we covered the egress to the endpoints over internet. So now we're going to move to another pattern that is quite popular with our customers. And in fact, I encounter this pattern a lot more as the time goes by, because more and more third-party providers, they actually end up in the cloud themselves, right? So in the past, if 10 years ago, the customer that I would work with, they would be on the AWS, like as maybe like one of the first customers inside the industry. Nowadays, like even their counterparts, their third parties, they also like sitting in the same AWS infrastructure. And so this pattern here, and I'm kind of gonna move my mouse and click on that so you can see it. But that connectivity pattern actually utilizes something called AWS Private Link technology. And so this technology was actually built specifically for use cases where you needed to talk between VPCs. You needed to talk to just in one direction. And yes, there are use cases where you can actually, which we'll talk about in a second, where you can provision private link in order to facilitate inbound traffic as well. But really the use case here that we're talking about is the ability for you to connect to third party, which is already on AWS, and be able to talk to their workload without having any kind of routing, any kind of VPC peering, or any direct network linkage to them, and all do it through private link. So with that, an example of a link there, or something that is frequently utilized for that would be like our marketplace offerings that you could go in and consume. And so a lot of them have the capability to just deploy a private link so you can consume. Another example is actually for you to consume AWS services, where you don't provision internet gateway, you have private link set up that provides you access to one of the AWS higher level service that does not live inside your VPC. So there's just a couple of examples and a couple of use cases there. And actually, I've seen examples where our customer was kind of big enough and important enough client, which almost triggered like a migration of their provider, of third-party provider, into AWS, and triggered them to establish presence within AWS in order to be able to provide that type of connectivity. Now, with that connectivity, you're obviously not talking to the internet. Private link only allows you to talk to very much defined destinations. So think about it as a much more secure version of connecting and talking to a third-party VPC. So if you've never used private link, definitely suggest to check it out. You could use it yourself, even within your environment, maybe even between like another subsidiary within your company, or maybe someone that you're acquiring. So that actually addresses a lot of different use cases. You can use it yourself. You can use it to connect to third parties. You can use it to connect to marketplace offering. You can use it to connect to AWS native services as well.
So we have a question from the chat. It's kind of slightly related to the private connectivity, but I think it's going back to some of the public connectivity that you mentioned earlier. So Kareem here is asking from an ingress perspective, but also looking at egress. I think we maybe want to tackle the first part of the question, that this is specifically for egress. I think you guys actually have a separate set of slides for ingress, because that is a slightly different beast from what I've seen at least. But then there's a ask about the elastic IP addresses. Like, how do you deal with elastic IP addresses? We just focus for egress, and Kareem will chat about the ingress use case in a second. But I think that's an interesting point that Kareem makes about, that remote third party might be expecting you to come in with a certain set of IP addresses. How do you deal with that, right? I think is it easier also with centralized, or is it easier with distributed? How do you deal with making sure that you maybe have a contiguous block of addresses, or public IP addresses that you can give to the third party? But, every time you provision a new thing, you don't have to go to them and say, hey guys, we've added the new IP address. Can you please update your policies on the receiving end?
Yeah, look, excellent question. I think the ingress or inbound pattern that we'll cover in a minute when we talk about like centralizing of that and how you manage elastic IP addresses or EIPs. But for the egress portion of it, well, with the centralized model, it's actually very easy, because inside the egress VPC, you would deploy a NAT gateway or an egress proxy, and they would be using consistent set of IP addresses. So obviously more than one, because you'd want to have resiliency across availability zones. But those IP addresses would stay consistent, and you could actually give those IP addresses to the third party. So not only you kind of come to them and authenticate with the identity information, but they can also leverage IP addresses for their filtering. And in fact, that's a very common use cases when you have environments going up and down, like for dev test, but your third party very much insists of you coming from a set of fixed IP addresses. So that does kind of work quite well for this use case. So that's how you kind of solve that. And with distributed, obviously the IP address allocation will be a bit harder than that. But some use cases where people bring their own IP addresses to AWS and a range of IP addresses. And so instead of giving out like IP address one by one, you can actually give out a range of IP addresses to the third party, and then use those IP addresses and allocate them to the different VPCs that you have across the environment. So I guess like there's solutions exist for that as well, but the centralized egress is definitely much easier from my perspective with that. I don't know, Shaquille, do you want to maybe add anything?
Yeah,
Okay.
we lost Shaquille for a second. Yeah. So there's a follow-up question which I think fits really nicely here about how many IP addresses you can assign, public IP addresses you can assign to the NAT gateway. Is it only one for egress? I know we've made some changes there, and now it's a slightly larger amount of addresses that we can assign. I don't know, Evgeny, if you want to talk about I think it's now a public offering that customers can come and request a contiguous block of IP addresses as well to assign to the resources.
Yeah, that's an excellent question. It sounds like an exam question. But yeah, look, NAT gateways, and sometimes you want to kind of reuse your NAT gateway, but have like more than one IP address on it for different needs. So definitely that's something that is super useful. I do think that we support now up to.
I think it's a /29, or is the maximum you can get.
Yeah, it's
I think
small,
if you can try and ask us and see tell us about the use case. There's maybe exceptions that the service teams could do, but I think without approvals, it's either /30 or /29 that you can request easily, allocate to your resources. So that's a really neat way. Request a couple of /29s. For most of your use cases. So really with NAT gateway, you probably won't really need more than one IP address. The only reason you need more IP addresses for NAT gateways is if you run out of ports. And that's run out of ports to the same destination, right? Because NAT gateway needs to keep track of all of your different things that the traffic is going to. And if, as the IP address of the NAT gateway talks to the same destination IP address, but then you hit 65,000 ports, you're going to run out of ports. And it's nothing to do with AWS. It's just the way the standards work. So if you need to connect to the same destination with more than 65,000 connections, you will probably need to add an additional IP address on the NAT gateway. I personally haven't seen many customers that have needed to add more IP addresses. So typically, it's just one IP address you have on the NAT gateway.
Yeah. Can I also say there's cost? Just a reminder that public IP is also cost as well. So you got to be mindful from that perspective.
That's a good call. You want to expand, Shaquille, on the cost bit?
Yeah, well, it's a tough one, but yeah. So when you're actually using public IPv4 in AWS, so there's a cost associated with those public IPs. So if you just want additional IPs without a good reason, you'll probably be paying some nominal cost for it. But generally, as an architect, you always question is there really a need for it? So if there is any, like Tom said, there's a very niche use cases where you actually need multiple IPs on the NAT gateways. I personally haven't seen in my many years of probably one customer who probably needed that IP. But in that case, yeah, it was valid. But otherwise, you probably won't need multiple IPs on NAT gateways in general.
Excellent. So then I know, Evgeny, we interrupted you. You started switching to talking about not using the public path, using the private path, using the private link technology. And do you want to expand on, is this available in a single region? So that third party has to be in the same region, or can the third party be in a different region? How does it work with the private link connectivity? And maybe some of the, what's the value of using private link over using the public path? What's the difference there?
Yeah, some good questions, Tom. I think maybe leading questions as well. So when we first built private link had tight dependency on network load balancer, and we only supported TCP for your private link as well as single region. Okay, so you kind of had to have your third party within the same region, and yeah, sometimes people did maybe daisy chaining of load balancers in order to kind of allow connectivity to another region. So there were solutions there, but again, there would be more sort of heavy lift, advanced type stuff. But actually, at the last reInvent, we released capability to do cross-region private link. So the way I think about it, I kind of have a mixed feelings about it almost. On one side, I really like it because it removes a lot of heavy lifting for customers, especially for service software as a service providers, for SaaS vendors. providers out there. It removes requirement for them to deploy into every region to service their customer needs. So they can deploy in a number of regions and then make their software available for private link for some of the regions where maybe they don't have as many customers, don't have the critical mass yet. And so that allows them to keep their cost in check and allow their customers from those other regions to access them using that cross-region private link connectivity feature. But also at the same time, I kind of go, well, I'd like to keep things in the same region. From resiliency perspective, as soon as you have dependencies on like other regions, that kind of expands the footprint. If something goes wrong in another region, like that is a dependency there, and things running in this region, but then maybe some parts of your application not working because now you took dependency there. So that's where kind of my mixed feelings about this come in. I'd like to keep things isolated, right, in a single region, and that I think has much higher, at least in my sort of professional experience, a higher resiliency about it.
Yeah.
Now,
it's just, sorry to interrupt. I have an anecdote about that because I did have a chat with one of the customers specifically about this cross-region private link, and their perspective was, we are going to do it anyway. We will build it ourselves, and we will build it worse than what AWS could offer. So could you guys please deliver the service? And then we did. And I think right now what customers are asking for is, can we do the same thing for AWS managed services, right? Could I have a presence of a particular service that's in another region in the other region? And that does create regional dependencies. But then customers are kind of already building it themselves, and they're saying, again, we're probably building it worse than AWS would. So could you guys help us do it in a more solid way? I agree with the sentiment of, it's not a great idea to create dependencies on cross-region connectivity, but there's some cases where you have to do it. So it's kind of nice that we deliver it and customers, set up private link cross-region.
Look, to be fair, it's not just our customers building that capability. Like if I look at Bedrock, they do cross-region inference. Even our services are building that type of capability themselves, right? So I know exactly where they're coming from. That's why I'm looking at that feature. But also at the same time, I go, well, there's some downsides, and as an architect, I'd like to. And so I did mention before that it used to be TCP and had high dependency on network load balancer, but we actually now support also UDP, and we also released something called Resource Link. So Resource Link actually allows you to not just target like an NLB or the other side of private link, but it allows you to be able to specify an IP address or maybe a fully qualified domain name. So it's super useful to point to things like maybe like databases or data warehouses, things like RDS and Redshift. So there's many like use cases, and private link continues to to address our customer needs. So super excited about private link. I think it's super beneficial to have that, and definitely provides you much tighter control over what you connect to, as opposed to the generic public internet capability. And you also pay for the data transfer, because typically that's within the same region, like less compared to data transfer out to the internet. I know we come from like in US, it's not as big of a problem, but in a lot of other regions where internet is actually a lot more costly, and there's ISPs, so internet service providers in local market have monopolies. Actually, data transfer out to the internet does cost extra per gigabyte compared to kind of like regions in US. And so there, if you have your provider convinced and deployed inside AWS and private link is there, it gives you a very easy way to securely access them. You know exactly who you're talking to, and it's also very cost effective at the same time.
Yeah, you're bypassing the NAT gateway. You're not having to deal with the public IP space at all, and just kind of private bypass of the NAT gateway to talk to a service hosted by your partner, or in this case it's Outbound, so hosted by your partner.
Yeah, exactly. Yeah. Cool. All right. So that's us talking about internet path and kind of the private path. The final one is the hybrid connectivity path. Okay. So a lot of our partners might be still in another provider, could be on premises, could be like even in a cloud, right? And in many cases, they have some sort of requirement to to connect to them privately. So that's where our hybrid connectivity services come in. Direct Connect would be the prime example of that. Dedicated, predictable, low latency, private connectivity, and that's something that you might be running into like a data center of your acquisition, or maybe like a third-party data center. And that's where you have full capability of how you configure and do different configurations with that. Site-to-site VPN continues to be something that a lot of providers out there also support, because it gives that additional layer of encryption, and you can configure that across Direct Connect or across internet. So either option is actually possible as well. And so we do see not as much as we used to. Like I used to work at a data center, and we used to create VPN tunnels to one of those ticketing providers. Amadeus, they fulfill like sort of airline bookings and things like that. And every time we needed something, like we needed to create like a connection, VPN connection to them. And the amount of troubleshooting and like that thing sometimes breaking, gives me nightmares still. Many years later, like almost 20 years later. So yeah, I don't see that as much anymore. I think technologies like Private Link actually like solve that use case like really well. As long as third parties within AWS, same on different region. But yeah, Direct Connect I do see occasionally, especially when you need like that predictable latency to the outside of AWS, or maybe to like another cloud provider. So definitely still out there.
Yeah, I think I've seen kind of similar. My experience is similar. So if you have a third party that is on AWS, you pretty much want to look at Private Link. And then if your third party is outside of AWS, what I typically see is actually a lot of VPNs. Maybe because I have a lot of customers in the financial sector, so it's like VPNs to different cloud providers, and there could be a lot of VPNs actually. So they kind of really good at setting up VPNs, dealing with that other side, because there are some dramas, like you said, Evgeny, right? When you're trying to set up a VPN, figuring out, make sure it works, then troubleshooting. But I know the kind of financial sector customers are really good at setting up VPNs. So I've seen them with hundreds of VPNs to different third parties outside of AWS. But as soon as that third party is in AWS, Private Link is your choice. I don't know, Shaquille, what is your experience?
I would echo your sentiment. I think one thing I've seen in financial segment is also the MPLS networks. For example, back in my FSI days, we used to have a third-party network dedicated MPLS connections going to identity providers. Like Evgeny mentioned, we have like identity verification, credit checks, external APIs you're calling in. I remember we used to get like connections, dedicated connections in their offices when they were on premises as well, just to, in some geographies, because your local regulator requires those connections to be private and encrypted, right? Things have changed, but yeah, absolutely right. I still, you guys mentioned the IPsec, VPN troubleshooting. Still give me nightmares. I still remember ISAK-MP logs and crypto and session tunnel debugging. So yeah, I don't fancy it, but things have come a long way. It's pretty easy. The one thing I love about Transit Gateway and Cloud WAN is that it's so simple to aggregate VPNs. Like it used to be a nightmare where you have performance challenges when you're building multiple VPN tunnels. Now the beauty of Transit Gateway and Cloud WAN is that you can aggregate your VPNs and create like a third-party zone or carve out a network within your Transit Gateway or Cloud WAN, which allows you to have that one point where third parties land. And then the pattern which you're getting talked about, the inspection, allows you to actually have that focal control point where you enforce these things as well. So yeah, absolutely great, same sentiment there.
Like a buffer zone, everybody lands in a particular route table or segment, and then before they can get to anything else, they're forced to go through a firewall.
Absolutely.
There's a question from Kareem. Thanks, Kareem, for all the questions. These are great. It sounds like we're paying you to ask these questions because they're really good. So Kareem is asking about kind of native troubleshooting tool for figuring out what's going on in your environment. So how do you know traffic or flow has reached the NAT gateway or VPC endpoint? Are the routing tables and security groups working? What are your thoughts? I don't think there's a single be-all tool that can achieve all of that, but there's a combination of tools that can help you.
Yeah, so like observability across complex network, I think has been something of a challenge, like in the complex networks in general. But in AWS, we actually give you a number of different tools that make your job and life a little bit easier. So I'll give you just 2 or 3 examples because we do need to cover inbound panels. But Network Manager is one, right? Network Manager is something that you use to manage your Cloud WAN, or you could also add your Transit Gateway to that. And it gives you ability to see different parts of the configuration, visualize it, your network, see route tables, and then see different events happening on your network. So that's definitely first one in your toolbox. Okay. The second one, we've got reachability analyzers. So you can actually go in and specify source A and kind of destination B, and then see where the traffic can get from A to B and where the problem is. Okay, so that's super useful for configuration and troubleshooting. Then there's also things like flow logging. Okay, so flow logging is probably the one which, well, it's very powerful. You can go enable that on your Transit Gateway attachments, your VPCs, right? And you can see exactly the flow logs. But then going through the flow logs and then kind of stitching it all together, that could be a challenge. Okay, and that's where my most favorite tool ever is CloudWatch Log Insights. That's actually where you can go, and within AWS console, within CloudWatch, you can actually write a query, and you could go in and surface your logging from your firewall, from your flow logs, from multiple VPCs, and the sky's the limit. But it's it can get complicated in terms of the syntaxes. Okay, so if you ever done your regexes in the Linux Bash shell, you probably right at home. If you haven't done that, then it could be a little bit challenging, right? But that tooling is absolutely gold. My go-to if you need to do some sort of ad hoc troubleshooting. And as you're doing that troubleshooting, you can leverage the CloudWatch dashboard. You can actually start adding queries in there, and you can create different views for yourself. So yeah, there's definitely a whole bunch of different native tools that are available for you to manage complex networks.
Nice. Thanks, Evgeny. I think we're going to let you crack on because we have 10 minutes left, and I know we have the ingress and bidirectional use case. We might just focus on the inbound if we'll see how many questions pop up.
Cool. All right. So let's talk about inbound pattern as well. And look, I think pretty much everything Evgeny already covered. You might be running, API access for your customers, your third parties in a B2B setting. You might be hosting a SaaS, application on your side, or you might be integrating a SaaS with some other tooling, or for example, BI tooling, where you need to have some business intelligence tool collecting data from somewhere, right? So again, same diagram. The only difference is we added the workload VPC1 here. You might have the one pattern where traffic is coming directly from the internet going into the VPC directly in a distributed fashion, and we talk about distributed in what fashion it probably can work and what are the caveats around distributed. You can have that network firewall or gateway load balancer based appliances in that VPC, which will allow you to have that choke point or inspection point for the traffic to come in and enforce the policies and before it hits the workload. And then the second pattern on the right side, if you have a look, that we have the same inspection in the middle, but on the right side, we've created these dedicated ingress VPCs. Now, these VPCs can have your load balancers, for example, ALB here. ALB might be terminating the connections. And I know Tom actually wrote this very nice blog around how to host, the ingress patterns as well. So probably something we can link in the chat as well. So yeah, so you can actually have that dedicated VPC where you terminate the connection and then build your ALB sandwich and bring that traffic back via Transit Gateway and Cloud WAN into the firewall, and from firewall back to your workloads in VPC1. So that's one pattern. You on the screen, we also have the client VPN. So you might be using client VPN in a VPC. Again, client VPN can be terminated in a VPC itself. So you might actually terminate that client VPN within that ingress VPC, which is kind of locked now, because in the ingress VPC, you're actually locked into that route domain within Transit Gateway or Cloud WAN, for example, which only allows you to actually go to inspection VPC, which means that even if you have third parties or contractors dialing into your network, they have to go via the inspection zone, and then they can only hit your VPCs as well. And lastly, the private link. I know Evgeny talked a lot more in detail around private link, how you can actually connect to third parties. Same principles, won't add more details, but exactly the opposite way, that you can actually have your third parties or other providers can come into your workloads into a VPC where you have private link deployments. For example, you might have network load balancer deployed in the ingress VPC, which is actually targeting the workloads back into the workload VPC via Transit Gateway, and it has to go via the inspection zone as well. So kind of the same as inbound, but then you might have a dedicated ingress VPC depending on where the third party is coming into your network as well. And again, at the bottom, you still have the hybrid use case, direct connect, site-to-site VPNs. You might have SD-WAN on premises, which might be coming over the direct connect, for example, and then again, take them down to the inspection zone in the Transit Gateway or the Cloud WAN and bring it back to the workload VPC as well.
Shakil, do you want to maybe, because it sounds to me like it's very similar to what we just talked about for outbound. You were just now, you previously for outbound, you were the consumer of a third party's thing. Now the third party needs to consume the you host. Maybe we can go back to the question from Kareem about like IP addresses and how do you deal with presenting a contiguous block of IP addresses to your consumers? I guess that would be the use case for connecting over the internet versus connecting over things like private link. And with private link, we know that you don't have to deal with any of that; it's just magic. But for when you're presenting stuff to the internet and you're required to have a consistent set of IP addresses, what are your options there?
So, for example, a good question. I think it's more relevant for what Kareem actually asked in the inbound, because you can actually have allocated elastic IPs in your account, or you might be doing BYOIP, for example. You might be bringing in your own cyber as well into the account, and then you can use those IPs with the ALB, for example, right? So you might have load balancers which are using those dedicated IPs or allocated IPs from our pool of elastic IPs, which you can present to your third parties. Ideally speaking, it should be an FQDN, but I get it. Like some firewalls, some firewalls can't use the FQDN based rules. So you probably have to present some side of IP addresses to your customers. So absolutely you can do that. If you require dedicated IP addresses, either try to bring your own IP pool, or you can actually use our elastic IPs as well, and then have them in their account before you actually allocate to the load balancers or EC2 instances, depending on what kind of appliance you're terminating the connection on as well.
And maybe I'll add a couple of other things here to what Shakil just mentioned. So inside that ingress VPC, if you wanted static IP addresses to your customers, you typically want to use NLB. NLB can scale horizontally without changing IP addresses. Unlike application load balancer, which in order to scale, IP addresses will consume them and they can change based on scaling in and out. So there's actually a pattern to have NLB pointing to ALB. And so ALB under the hood can scale horizontally in and out, but NLB in front stays and has static IP addresses provided to your customers. Now, ALB itself, interestingly, has ability to do different routing rules to multiple backend applications based on things like paths and host headers and like different rules that you set up. So there's a lot of ways that I guess that they go a lot more advanced topics, right? I would actually suggest to have a look at our YouTube channel and have a look at the recordings from reInvent around those topics. But there's many capabilities of load balancers where you can actually have traffic split in a different direction depending on your request, depending on your client, and you can definitely achieve that static IP address capability to your clients as well.
I know you mentioned, Tom, the pattern is very similar to inbound. I actually want to go to the next slide again, if you can. So when we talk about inbound and outbound connections, pretty much similar, but when we talk about bidirectional, there are a few additions in there. If you look at this slide, we actually added like VPC pairing in here because you might require some proprietary protocols for your customers. And we see this often, like when there are proprietary protocols, private link might not be the right option, and you might actually want to do something like VPC pairing. Or we also launched ENI sharing, for example. If you're not aware, this is a feature where you can actually share your ENI in another VPC as well. So if you go to the next slide, you'll probably, on the left side here, you can see the VPC2, where the workload VPC is connecting to a third-party VPC using VPC pairing, which is kind of it's a pattern, but not really a good pattern because you're kind of exposing your VPC to your partner, which is a fully exposed VPC. which kind of means you can still use security groups, but I would actually I would caution here that you should only use this pattern with partners you fully trust, because you're opening up your whole network to another network, right? So you kind of want to make sure that these third parties are fully vetted, or your compliance requirements are fully met. Evgeny, do you want to add something here?
Yeah, sure, Shaquille. And it takes a little bit of muting our microphones away. But yeah, I think what we wanted to demonstrate here is that those patterns that we were talking about before, they're the patterns that we see that work really, really well, and they are majority of our customers use them and have a good day. And VPC peering is something that we've seen a lot in the past, but as we've created more sophisticated ways to connect and consume applications from other networks, as well as expose applications to other networks and comments, we see that VPC peering kind of is going away. Okay, but every now and then I go and read some doc somewhere for like an integration, and then I see this older pattern still out there. This is more for your awareness. Yes, it can be bidirectional, but inserting like firewall in the path, for example, with this pattern, it's harder. Like, you can't actually like transparently insert it easily because there's no some of the ingress routing capability is not there. And so this is more for your awareness, because you probably will see it. It's not going to go away magically. You might work on a network which is a bit older, and they still utilize that, or you might go and run into some sort of third-party provider who still use that as a possible pattern. And so when you see that, what you should remember is that, hey, this is perhaps not the best way of doing things, right? And sometimes it takes you to insist on, VPC peering is what you support. Is there any other way that we could do it? Okay, and sometimes you do need that bidirectional connectivity, and there's lots of applications talking to lots of applications, and maybe private link is not ideal in this case. And so, yeah, that's still possible and available, but there's definitely an element of trust when you set up VPC peering. That's what you should probably know about the option.
Yeah, I would just say I've seen this pattern working where a third party is building a dedicated environment just for this customer, and where they actually want to access, for example, databases or some proprietary protocol where this application third party is building for this customer has to access some data freely, right? So, and then generally speaking, I've only seen where like it's dedicated third party VPC for you as well. But yeah, you're right. It's a very uncommon pattern, but it is a pattern in some cases where you need that bidirectional support. John?
Okay, we got a couple of minutes left, so I don't know if you guys have another quick pattern you want to show, or we slowly need to start wrapping up.
No, I think we can say thank you. I know that there's 100 of you on the this across the platforms, so thank you very much for watching. It's been a blast. I'd like to invite you to the routing loop to the next session. I think we're going to have it list, and I believe Tom have shared the link. So yeah, keep coming. We're going to cover lots of exciting topics throughout the year, and yeah, let us know if you'd like us to talk about a specific topic in one of the upcoming sessions. And also, like if you think we're missing some sort of capability on AWS, yeah, come back to the next one and call it out. We'd love to hear from customers about the things that we can build for you to make your networking life easier.
Yep. Thanks, everybody. Thanks for bearing with us in this very unique situation here, all of us being in the same room. Thanks, and see you all next week.
Thanks, everybody.